Find the equation f of x equals a times x minus h squared plus k for a parabola containing the point -1, 0 and having -3, 4 as a vertex. And then the second part of the question says, what is the standard form of the equation? Well, they've given you this. F of x equals a times x minus h squared plus k, which is what kind of form for a parabola? Vertex form. Now, we can fill in the information given to us in the problem. Right now, we do not know what the a is, so I'm just going to leave a blank. But x minus h squared plus k. Do we know the h and the k? What is h and k of a parabola? The vertex. Well, didn't they give us the vertex? So that's your h and your k. So think about it. If you take -3, which is the h value, and you plug it in right here in the formula, won't that minus and negative become a plus? And then if you take 4, which is the k of the vertex, and you plug it in right here, we now have x plus 3 plus 4, which rules out b and c. Then when you look at a and d, what's the only difference in their vertex forms? Correct. This one is a positive one in the a place. This one is a negative one. Well, the way I figured out that it should be the one with the negative is because of this other point. I just quickly did a little sketch. I know that the vertex is left 3, up 4. So if I go left 3 and up 4, the vertex is right here. If the other point is at -1, 0, isn't it below the vertex? Which means the parabola will open down, which is why you need a negative out front. Since this is the only one that has everything right and none of them match, you don't even really have to worry about this part of the problem. The only time you would have to worry about that is if like these had been identical. But since they're all unique, once you know this is the right equation, then this is the right answer. You don't have to worry about the rest. Does that make sense? Okay, now before we start today's lesson, I'll take just a few questions off of pages 10 through 13. Were there any that you really just could not figure out the numbers for? Number what? 12? Okay, number 12. What are numbers that multiply to 20? Okay, and 5 and 4 are one unit apart from each other, correct? So that's looking good. But to get a 1, when you add them, it needs to be a 5 and a -4, because 5 minus 4 is 1. 5 times -4 is -20. Okay, other questions? Okay, Marcus? Okay. Number 29. What are the first two numbers you think of when you're multiplying to 81? 9 times 9. And can't you do 9 plus -9 to give 0 and 9 times -9 to get -81? Okay, what else? 26. All right, what are two numbers that you think of that multiply to 14? 14 and 1. Some of you may have thought 7 and 2. But if you're adding to get a 13, you're going to have to use this 14 and 1. 14 minus 1 is 13. And 14 times -1 is -14. No, because a -14 plus 1 would be a -13 when you add them. See, the sign up here doesn't really matter. Listen. When you're multiplying, it wouldn't really matter which one's negative, because as long as one's negative and one's positive, you'll get a -14. But down here, it does matter. If you want your answer to stay positive, you need the bigger number positive. If you want your number to be negative, the bigger number should have been negative. And then whatever you choose down here has to be the same up here. Okay, other questions? Okay? Number what? 50? All right, number 50. What are some numbers that multiply to 144? Correct. Now, I'm pretty confident that y'all didn't just think of those numbers right away, correct? Most of you probably started with 12 times 12 and realized that's not going to work. At that point, you're going to have to pick up your calculator. Since 144 is an even number, I would just start by dividing it by 2. And that gives me 2 and 72, which is not going to add to a 32. Then I do 144 divided by 4, and that gives me 4 and 36, which are 32 units apart, so those are my numbers. Okay, 4 and 36 are my numbers, but if you want them to add and go into the negatives, which one of these numbers needs to be the negative? The bigger number, the 36. Okay, so sometimes you're going to have to use your calculator and just guess and check till you find the right numbers. Okay, any other questions? Okay, which one? 36? Okay, what numbers multiply to 121? 11 times 11, and those numbers will also add to 22. 40? All right, what numbers multiply to 256? Right, 16 times 16, but they need to add up to be a negative 32. Turn around, which means both of them need to be negative. Okay, now I want you to put your pencil down for a minute, and I'm going to do some examples to lead into today's lesson. Okay, so you're not going to write these down, you're just going to pay attention for the next couple of minutes. Today we're going to learn a process called factoring. Okay, now before we start it, I just want to go over something. If you were given a problem that looked like this, and you were told to simplify it, what would you do? You would distribute. 3x times x is 3x squared. 3x times negative 4 is negative 12x, which is what we have here, correct? Well, today we're going to learn a process called factoring. And basically when you factor, all you're doing is undistributing. So let's talk about how that works. When you factor a binomial, you need to look at both terms and you need to write out their prime factors. Now what I mean by that is to get a 3x squared, you would multiply a 3 times an x times an x. To get a 12 is 3 times 4, but 4 is not prime, so it needs to be broken down into a 2 and another 2, and then x. Okay, so the first thing that you're going to do is you're going to take the two terms of the binomial and you're going to write out their prime factors. Marcus, pay attention. Now you're going to circle what they have in common. They both have a 3 and they both have an x. So since they both have a 3 and they both have an x, their GCF, which is greatest common factor, is 3x. Now, see how in the top, 3x squared, the x wasn't used in the GCF? So it goes back in. And in the bottom from the 12x, 2 times 2 wasn't used, so 4 goes back in. And then just bring down the minus. See? Well, we did factor trees where you had to do prime factors, yes. Okay, so do you see now how you basically undistributed the 3x from this problem? Last week we were learning how to distribute. Now we're given this and we're going to undistribute, which is really called factoring. Okay, so now let's try this one. If you saw this last week and you were told to simplify it, you would have distributed r squared times r is r cubed, and r squared times a is negative 8r squared. But today we're going to learn how to factor. They're going to give us this, and we're going to get to there by factoring. So you write down the terms, and you list out their prime factors. To get r cubed, you do r times r times r. To get 8r squared, 8 is 2 times 2 times 2, because that's a 4, and then times 2. And then times r for the r squared. Now that you have their prime factors listed out, you circle what they have in common. They both have at least 2 r's in common, and r times r is r squared, so that's their GCF. Now what they didn't have in common from the r cubed was just an r, and then bring down the minus, and from the 8r squared, 2 times 2 times 2 is 8. And see how that matches up with what it was before it was distributed? Okay, so now let's try some in the packet. So go to page 8. Okay, number 1 and 2 were the problems that I just used, so we can go ahead and just write those answers down. For number 1, it was 3x on the outside because that was the GCF. That was what both terms had in common. And then x minus 4 on the inside. For number 2, it was r squared, and then on the inside, r minus 8. So now let's try number 3. Okay, number 3, I'm looking at a binomial, and my directions are to factor it completely. To factor it, I need to see what it has in common. That means find its GCF. So I take the two terms, and I list them out on the side. To get v squared, it's v times v. To get 7v, it's 7 times v. So what do the two terms have in common? Just a v. 1v is all they have in common, so 1v is your GCF. Now, from the v squared, v was not circled. From the 7v, the 7 was not circled, so that's what goes back in. How do you think we could quickly check this to know that we did it right? Just distribute it back out in your head. V times v is v squared. V times 7 is 7v. So that's how we know we're right. Okay, now let's look at number 4. I want to factor this binomial, and so I need to see what those two terms have in common. P squared is just p times p, and 10p is a 5 times a 2 times a p. So what's the only thing they have in common? A p. 1p. So 1p is your greatest common factor, so you factor it out. You undistribute it. Factor it out. Out of the p squared, p was left uncircled. Bring down the plus. And from the 10p, 5 times 2 was left uncircled, so 10. Then you can just quickly check it. P times p is p squared. P times 10 is 10p. You starting to get the hang of it? Okay, now let's look at number 5. 6m cubed minus 12m squared needs to be factored. To factor it, we see what they have in common. So we list out both terms. Okay, the prime factors of 6m cubed are 2 times 3 to make the 6, and then m times m times m to make that m cubed. The prime factors of 12m squared are 2 times 4, not 2 times 4, 2 times 6, which is 2 times 2 times 3, correct? Or you could look at that as 4 times 3 to make the 12. And then m times m to make the m squared. So now that you've listed out every prime factor for both terms, you circle what they have in common. They both have a 2, and they both have a 3, and they both have 2 m's. Right? So 2 times 3 times m is 6m squared. So that is their GCF. Whatever you circle, you multiply together. 2 times 3 is 6. M times m is m squared. Now what was left from the 6m cubed was just the m. And then bring down the minus. What was left from the 12m squared was just the 2. Now you can quickly know if you did it right by distributing out in your head. 6m squared times m is 6m cubed. 6m squared times negative 2 is negative 12m squared. Any questions? Okay, let's try one more together before I let you try some. Yeah. 5x squared and 35x. What are the prime factors of 5x squared? 5 times x times x. What about 35x? 5 times 7. Okay, now we need to circle what they have in common. They have a 5 in common, so you pull it out. And they have an x in common, so you pull it out. That is the greatest common factor. Now, from the 5x squared, x was not circled, so it goes back in first, because 5x squared was first. Bring down the plus. From the 35x, the 7 was not circled, so it goes second. And then you can quickly distribute it back out. 5x times x is 5x squared. 5x times 7 is 35x. Now I want you to take a couple of minutes and try 7 through 10. 7, 8, 9, and 10. The right answer was A on the outside is the GCF, because that's what they both have in common, and then on the inside, A minus 8. For number 8, B was the GCF, because that's what both terms have in common. It's just one B, and then B plus 8 is left on the inside. Any questions about those two? Do you need more explanation? All right, number 9. Okay, for number 9, out of k fourth and 10k cubed, they have k cubed in common. They both have at least 3 k's in them. And then that leaves k plus 10. Okay, and then for number 10, they both have at least 5 in common, because 5 will come out of 5 one time, it'll come out of 24 times, and they both have at least one b in common. That leaves b plus 4. Any questions about those two? Yes? Okay, well when I list out the terms 5b squared and 20b, the prime factors of 5b squared are 5 times b, and the prime factors of 20b are 5 times 2, because that's the 4, times b. So they have a 5 in common, which is right there, and a b in common, which is right there. From the 5b squared, which is first, only the b was left. And from the 20b, which was second, only 4 was left. Okay, now let's look at number 11. Do not write this, though, okay, because what I'm about to write for number 11, I'm going to erase because it's wrong. If we attempt number 11 in the same way, if I take 9x squared and 1, and I try to factor them out, 9x squared would be 3 times x, and then 1 would just be 1, right? Or 1 times 1 at the most. Well, is there anything in common? No. So you cannot factor this type of binomial by pulling out the GCF. What? Okay, so we cannot do it the same way. This is a special case. This is a binomial, This is a binomial that's a special case. So now put down your pencil, and I'm going to do a couple of these. Okay, this binomial is called a difference of 2 squares. Now, you see how it's obviously a difference because subtraction. And the reason it's called a difference of 2 squares is because this is a perfect square and this is a perfect square. The reason 9x squared is a perfect square is because 3x times itself is 9x squared. That's what it means to be a perfect square. Like, that's why 25 is a perfect square. 5 times 5 is 25. 1 is also a perfect square because you can do 1 times 1. So since you're subtracting these and both of them are perfect squares, that's known as a difference of 2 squares. Now, I'm going to go back to page 5 for a second, but just watch. You don't have to go back. Oops, wrong flip chart. I think it's this one, yeah, okay. Okay, the other day when we were working page 5, and we had something like this, and you were supposed to distribute them, see how everything's identical except for the signs are different? But they both start with 3 and they both end with 7x. The only thing different about them is the plus and the minus. Well, watch what happens when I double distribute. 3 times 3 is 9. 3 times negative 7x is negative 21x. 7x times 3 is positive 21x. And 7x times negative 7x is negative 49x squared. What happens when I simplify? Right, the middles cancel out, and you're just left with the 9 minus 49x squared, which is a binomial. Normally, when you multiply normally when you multiply two binomials together, like, okay, watch this. 7a times 8a is 56a squared. 7a times negative 4 is negative 28a. Negative 6 times 8a is negative 48a. And negative 6 times negative 4 is positive 24. Then you would combine those like terms in the middle, which becomes a negative what? 76a plus 24. See how normally when you multiply two binomials together, you're left with a trinomial for your answer? Well, whenever you multiply two binomials that are identical except for their signs, you end up with a binomial because the middles cancel out. This is a special case. It's a difference of two squares. Isn't 9 a perfect square? Because 3 times 3 is 9. And 49x squared is a perfect square because 7x times 7x would make 49x squared. So now, let's look at, you're going to factor this into two binomials. What times what would make 9x squared? Times 3x. And what times what would make 1? 1 times 1. But in order for it to be a negative 1, you've got to have opposite signs. And since they're identical except for their signs, that's why the middle canceled out and you just have a binomial. Okay, so now let's look at example 4. This is a difference of two squares because isn't a squared a perfect square because a times a would make it? And 25 is a perfect square because 5 times 5 would make 25. So you factor it into two binomials. A times a is a squared. 5 times 5 is 25. But to get it to be a negative 25, one has to be positive, one has to be negative. And then think about it. We know this is the right answer in factored form because a times a makes the a squared. 5 times negative 5 makes the negative 25. And then look up for a second. Wouldn't the outside terms make a negative 5a and the inside terms make a positive 5a, which cancels out, which is why there's no just regular a up there, it's missing? Okay, so this type of binomial is a special case. It's called a difference of two squares, and it'll factor into two binomials that match except for their signs. So now let's try some of these on page 8. Okay, so the first example we did was number 11. So you can go and write in 3x plus 1, 3x minus 1. And then the second example we just did was number 14. A plus 5, a minus 5. Okay, now look at number 12. Is it a difference of two squares? Yes. 16 is a perfect square because 4 times 4. 1 is a perfect square. 1 times 1. So you factor it into two binomials that are identical except for their signs. They have to be opposite signs, otherwise the middle wouldn't cancel out. And then to get 16x squared, isn't that just a 4x times a 4x? And to get 1, it's just a 1 times a 1. That's all you do. Okay, so now for number 13. This is a difference of two squares because it's a difference and both terms in the binomial are perfect squares. What do you have to multiply together to get 4n squared? 2n times 2n. What do you have to multiply together to get 1? 1 times 1. But to make it a negative 1, opposite signs, and the fact that they're opposite signs but everything else is the same causes the middle to cancel out because outside would make a negative 2n, the insides would make a positive 2n, which would cancel each other out. Okay, next page. Okay, number 15. Is number 15 a difference of two squares? Yes, it's definitely a difference, and then both terms are perfect squares. What times what is 25x squared? 5x times 5x, and what times what is 4? 2 times 2, but right, one would have to be positive, one would have to be negative to make it a negative 4 and to cancel out the middle. Okay, I'll do one more with you. Let's look at number 21. This is also a difference of two squares because 25x squared is a perfect square because to get it, you just multiply 5x times itself And then 4y squared is a perfect square, because to get it, you multiply what by itself? 2y. But then just make sure you have opposite signs so that it's negative 4y squared, and so that the middles cancel each other out. Because look, if you were foiling, the outsides would make a negative 10y, or actually a negative 10xy, and the insides would make a positive 10xy, which would cancel out. Do you now know how to do these? Okay, you need to work on this page. Whatever's not finished is homework. Page 9, yeah. And they're all like this, so they're pretty easy.